Have you ever wished you had a crystal ball for your business? Some way to peek around the corner and make smarter, more confident bets? Well, what if I told you that tool is probably already sitting on your computer? Today, we're going to pull back the curtain on probability distributions and see how they can help you forecast your business's future. I know. That sounds like a huge claim, right? Predict the future? But look, while you can't predict things with 100% certainty, who can? You can use data to map out the likely possibilities, and more importantly, understand the odds. And that, my friends, is an incredible advantage. And we're not talking about some vague finger-in-the-air kind of guessing. This is all about putting real numbers to uncertainty. How many customers are going to walk through that door in the next hour? What are the actual odds of hitting your sales quota this month? And will that massive project really finish on time? Probability helps us tackle exactly these kinds of questions. So where do we even begin? Well, the first big idea you need to grasp is that all your business data basically lives in one of two different worlds. Figuring out which world your data belongs to, that's the key to choosing the right predictive tool for the job. So on one side, you've got discrete data. These are things you can count in whole numbers. Think customer complaints, deals closed, items returned. You can't have half a complaint, right? Then on the other side, there's continuous data. These are things you measure on a scale, like sales revenue, project duration, or temperature. Each of these worlds has its own unique set of tools. All right, let's open up that first toolkit, the one designed for discrete, countable stuff. These are the models we pull out to answer all those how many questions that pop up in business every single day. Let's get our hands dirty with a classic sales scenario. Okay, picture this. You've got 10 meetings lined up. Each one is a shot on goal. It's either a success or a failure. How in the world can you figure out the chances of hitting a very specific target, like closing exactly 4 of those deals? Well, for this exact type of problem, our secret weapon is the binomial distribution. It is purpose-built for this. It's designed to calculate the probability of getting a specific number of successes, like, say, closing a deal, out of a fixed number of attempts. And check out how beautifully this problem breaks down. All we need are 3 little pieces of information: the total number of trials, which is our 10 meetings, the probability of success for each one, let's say it's about 30%, and the exact outcome we're curious about, in this case, 4 deals. That's all it takes. Okay, now for a slightly different how many question. What if you're not looking at a set number of attempts, but instead you're interested in the rate at which something happens over time? For instance, what are the odds of having exactly 2 machine failures today if you know that on average you get 1.5? And for this, we've got another amazing specialized tool, the Poisson distribution. This is your absolute go-to for understanding things like calls coming into a call center, customers arriving at a store, or, just like in our example, equipment breakdowns over a set period of time. And you know what? The setup is once again incredibly simple. The only bit of historical data we need is the average rate of the event. Statisticians call this lambda, which is 1.5 failures a day. With just that single number, we can calculate the probability of seeing any number of failures. It's that powerful. All right, let's switch gears and jump over to that second world of data we mentioned, the continuous world. Now, instead of counting distinct events, we're measuring outcomes that can fall anywhere along a spectrum. We're shifting our focus from how many to how much. And the undisputed champion in this world is the normal distribution, which you probably know as the bell curve. Seriously, this thing shows up everywhere in business. And there's a good reason. When lots of little random factors all influence an outcome, the results tend to bunch up around an average, creating this classic bell shape. Just think about sales figures, employee performance scores, even stock returns. So let's see this in action. An admissions office has a really practical problem. They want to be selective, right? They've decided they only want to consider the top 20% of applicants based on GMAT scores. So how do they figure out the exact score that separates the top 20% from everyone else? Well, everything kicks off from the center of our bell curve, the average score, or the mean. In this scenario, that's a 550. This one number is the anchor for our entire distribution. It's the most common score right there at the peak of the bell. And this is where the magic really happens. By using the known properties of the normal distribution, that admissions office can calculate the precise cutoff score. Bam! To be in that elite top 20%, an applicant needs a 617. It just transformed a vague goal into a clear, data-driven number. Okay, so this all sounds great in theory, but the big question is,
How do you actually do it? Well, here's the best part. You don't need a PhD in statistics or some fancy software. You just need a tool you almost certainly already have. Good old Excel. For our sales manager's problem, it's as simple as this. You take the numbers we already figured out, 10 trials, 0.3 probability, and 4 successes, and you just plug them into Excel's built-in binom.dist function. That's it. It does all the heavy lifting for you. And it's the exact same idea for our machine failure problem. You just take your average rate, that lambda value, and pop it into the poisson.dist function. In seconds, you can find the probability of any number of events. It's almost too easy.
And for the normal distribution, you guessed it, the logic is exactly the same. You'll need your mean and one other number called the standard deviation, which is just a fancy way of saying how spread out is the data. With those two numbers, the norm.dist function unlocks all the predictive power of the bell curve.
So let's zoom out and bring this all home. Because remember, the whole point of this isn't just to crunch some numbers for fun. It's to move from looking at raw data to making confident, strategic, and much, much smarter decisions. So here it is, your new decision-making cheat sheet. The first question you should always ask is, what kind of data am I looking at? If it's a series of yes-no or success-fail trials, your tool is binomial. If you're measuring the rate of something happening, like arrivals or defects, you're going to want poisson. And for just about any other measurable thing that clusters around an average, the normal distribution is going to be your best friend.
Look, this isn't about having a perfect crystal ball that never fails. It's about having a much clearer one. You now have a framework to actually quantify risk and spot opportunities in a powerful new way. So the only real question left is, what piece of your business's future are you going to illuminate first?